This video is part 2 of my DIY MPPT project. In part 1, I designed the control board for the MPPT charger, and in this part, I'll finish designing the remaining power board. I split the design into 2 separate boards to make manufacturing and future repairs easier. Like my other videos, JLCPCB is supporting me again in this one. They sponsored the PCBs for this project, and honestly, many of my projects wouldn't have been successful without their help. Right now, JLCPCB is offering huge discounts on 6-layer PCBs with lots of coupon codes worth up to hundreds of dollars. With their advanced technology, their PCB and PCBA quality is among the best in the industry. Sign up using the link below the video to get these deals today. I'm using EagleCAD to design this PCB. You can download the files I've provided in the description below this video. You can also open them on the Easy EDA website, which is part of the JLCPCB ecosystem. From there, you can edit the files and order the PCB directly from the website. If you want to build this project as well, you can log in to JLCPCB and upload the Gerber files I've provided. JLCPCB will start manufacturing your PCB right away with excellent quality. Normally it takes about 7 to 10 days to receive the boards. I live in Vietnam, so shipping is fairly quick for me. If you're farther away, it might take a bit longer. This is the main power board I just received from JLCPCB. As always, the quality is flawless. I'm using an 80A relay to switch the battery input, and I'm also running 2 buck converters in parallel. In the near future, I plan to try an interleave 2-phase buck design. I've heard it performs better. Since this is the first version, the main goal for now is simply to get the circuit up and running. The first thing we need to do is solder a few SMD components on the board. In the next version, I'll try to move all the SMD parts to the control board. That should make the main board cleaner and also easier to manufacture. Next comes installing the larger components, such as the capacitors, inductors, and diodes. In this design, I'm not using a synchronous buck like in the original design. I've found that synchronous bucks aren't as robust as non-synchronous ones and tend to fail more easily. Even though the efficiency is a bit lower, that's not a big problem. We can simply add another solar panel to make up for the loss. Since this design uses 2 buck converters in parallel, I plan to populate only half of the components for now. The goal is to get the circuit working, so there's no need to fully populate everything at this stage. A small issue came up. The seller sent me the wrong type of relay, so I couldn't solder it onto the board. For now, I'll just bypass the relay so I can continue testing. And this is what the finished unit looks like. The cooling fan will blow air into the center to cool the MOSFETs, diodes, and capacitors. One cooling fan is more than enough for this setup. I'll connect it to a 12-volt lithium battery pack for testing. This MPPT circuit can deliver up to 60 volts output and supports up to 150 volts input, which is more than enough for my needs. This circuit also has multiple configuration modes, making it suitable for charging from solar panels or wind turbines. It lets you choose between lithium batteries or lead-acid batteries, along with many other settings. After connecting the circuit to the input, it starts operating. The duty cycle gradually increases, the MCU records the maximum power point, and then precisely controls the MOSFET drive pulse width to keep the output power at its maximum. After about 30 seconds of tracking, it finds the maximum power point. You can see this very clearly on my power supply. The power keeps adjusting and staying close to the maximum level the supply can deliver. I'll make a few small tweaks before connecting it to the solar panels. Stay tuned for my next video.